Abstract classes and interfaces. Definition: abstract methods is equal to methods that are declared with no implementation. Abstract class is a class with abstract methods. It is not meant to be instantiated. Interface is a name collection of method definitions without implementation. So these are all the definitions of abstract methods, abstract class and interface. Examples: food is an abstract class. Can you make an instance of a food? No, of course not. But you can make an instance of an apple or a streak or a peanut butter cup, which are the types of a food. So food is the abstract concept. It should not exist. Skills or interfaces. Skills are interfaces. Can you make an instances of a student, an athlete or a chef? No, but you can make instances of a person and have that person take on all these skills. Deep down, it is still a person, but this person can also do other things like study, sprint and cook. The question is, so what's the difference between an interfaces and an abstract class? The answer: an interface that cannot implement any methods, whereas an abstract class can. A class can implement many interfaces but can have only one superclass, abstract or not. An interface is not part of the class hierarchy. Unrelated classes can implement the same interface. Syntax: abstract class, public class, apple extends food. Interface: public class, a person implements student, athlete, chef. This is the syntax of a abstract class and interfaces. Question: why are they useful? The answer is, by leaving certain methods undefined, these methods can be implemented by several different classes, each in its own way. Example: if you are taking example, chess playing program, an abstract class called chess player can have an abstract method make move extended differently by different subclasses. Public abstract class chess player. So the methods are variable declarations, method declarations, public void make move. So function over here. An interface called chess interface can have a method called make move implemented differently by different classes. So public interface, chess interface, so public void make move. What about inheritance? Follow these simple rules. An abstract class can't inherit from more than one other class. Interface can inherit from other interfaces, and a single interface can inherit from multiple other interfaces. Interface: singer, void string, void warm up, voice. Interface: dancer, void dance, void strength leg, stretch legs. Interface: talented extends, singer, dancer can sing and dance. Where else can interface be used? You can pass an interface as a parameter or assign a class to an interface variable, just like you would to an abstract class. Example: food, my lunch is equal to new sandwich. Food, my snack is equal to new apple. Student Steve is equal to new person. Assuming that person implements student. If person has methods eat, food of F and teach student S, the following possible. Person Bob is equal to new person. Steve dot teach of Bob. Steve dot eat my lunch. System dot out dot println yum. Data factories. I'm confused why we are using this. Robot R1 is equal to new robot AC. Robot R2 is equal to new robot AC. Robot R3 is equal to new robot AC. Robot R100 is equal to new robot AC a function. So now in data factories, robot R1 is equal to data factory dot make robot. R2 is equal to data factory dot make robot. Robot R3 is equal to data factory dot make robot. Robot R100 is equal to data factory dot make robot. So here public class data factory of public robot AC make robot. So return new robot AC, which implementations requires the most line changes if you made a design decision to use a new kind of robot called super robot for R1 minus R100.